Hey guys, this is something really interesting I've decided to do. This is my very first PJAS project back from 7th grade, and I'm trying to present this 4 years from now. So bear with me and I'll see how much of this project I remember. Now, basically, PJAS is a Pennsylvania Junior Academy of Science. It involves a regional level and a state level. If you get a first award at regional level, you get to go on to the state level, and then the whole process repeats again if you get a first or second at states too. Now, if you get a first at states, you're eligible for various special awards, especially from major companies and the Pennsylvania Science Talent Search. This project from 7th grade, as I said, was my first PJS project, and it won first place at both regionals and states. It is titled, Which Building Insulation Material Allows the Least Temperature Drop? And this was when I was in 7th grade in Springhouse Middle School. So some background knowledge that is required for this experiment is that insulation is a material used to reduce heat transfer. It is commonly used in the walls of buildings because it is a poor conductor of heat. It is important to note that more than 40% of energy used in an average American home is for heating and air conditioning. Therefore, insulation is a most effective strategy to save on energy bills. Without a good insulation material, even the best heating and cooling system will not save as much energy as improved insulation would. Some insulation materials work better than others. By using the best insulation material, a huge amount of energy can be saved for the household. Insulating materials are characterized by the resistance to heat flow, known as the R value. The higher the R value, the better the insulation. I chose this topic because I'm very interested in structural engineering, architecture, and energy related topics. Since I was young, I was always interested in saving electricity, and I'm also interested in architecture and have a home design system at home as well as CAD at home, so I thought this would be a perfect opportunity for me to display these passions. Energy saving is a very important issue today in the natural gas, oil, and energy prices are still rising, and renewable sources are the only way to bring these prices down. Something that I found interesting is that I often watch a TV show called Modern Marvels, and they once had an episode about building insulation. Yes, an entire episode. This episode inspired me to choose this topic for this experiment. So, based on our research, the problem statement is if equal size boxes were insulated with various insulating materials and placed outdoors for 60 minutes in a cold winter temperature, which insulator will maintain the highest temperature and the lowest temperature drop? And based on my research, if four different commonly used insulation materials, fiberglass foam, rigid foam, and Reflectex, were to be tested outside for 60 minutes for 14 days, then the fiberglass insulation would have the lowest temperature drop. This is because it is made out of tiny glass fibers with air pockets. This allows it to have a high non-conductivity and a high ability to capture air traveling through. To conduct this experiment, some materials that were required are 5 cardboard boxes, each a 20 centimeter cube. Owens Corning fiberglass insulation was required, as well was Owens Corning foam insulation. Reflectex reflective insulation was also required as a more modern alternative to these fiberglass and foam options. Also, rigid foam, a popular option in especially factories, was used. One vacuum food container was used to study how good an insulation of vacuum is. It was not really part of my project, but probably a lead in as a future avenue of my research. 6 thermometers required, clear packaging tape, scissors, and 6 weights to put on top of the boxes in case it was windy. First, I gathered all the required materials to start the project. I placed one thermometer outside and recorded the temperature. After that, I lined all the 6 boxes with insulating material 2 centimeters thick. I recorded the temperature inside. This would be the start temperature of each box. I placed the thermometer in each box without the insulation. I sealed all the boxes with clear packaging tape, making sure there were no leaks. I placed a thermometer in the food thermos as well. After that, I recorded the outside temperature and placed all 5 boxes in the food thermos outside. I place a weight on the boxes so the box don't get blown away. After 60 minutes, I placed all the boxes back inside and recorded the temperature immediately. I found the temperature change of all the boxes and the food thermos. I repeated these steps for 13 more days for a total of 14 days or 2 weeks. And then I created a data on the chart and created graphs based on the data. The control variables of this experiment were the outside temperature, starting temperature, dimensions of each box, and the thickness of the insulation. The manipulating variable was a type of insulation, and the responding variable was a temperature drop. Here are 4 pictures of my experiment. The first picture shows the 5 regular insulation boxes. As you can see, this box had no insulation group since it was a control group. And then this is Reflectex, this is foam, fiberglass, rigid foam. This is a thermometer we used. This is the food canteen we used to simulate the vacuum panel insulation. And this is a set of 5 boxes outside. This is a chart of the data of the temperatures. As you can see, these are the outside temperatures in degrees Celsius, and these are the inside temperatures. And here are the temperature recordings after 60 minutes outside for each box. As you can see, the vacuum panel obviously had the highest temperature, and obviously the box with no insulation had the lowest temperature. This is a more concrete example of comparing these data onto graphs. As you can see again, the inside temperature and the vacuum panel, there was not much difference in between those two on the specific days. However, between the inside temperature, the no insulation box, and the outside temperature, there was very little difference between these two. This is a final graph showing the average temperature drop of each box. The average temperature difference between indoor and outdoor was 21.3 degrees Celsius. As you can see, the box with no insulation obviously had the highest temperature drop, and the vacuum panel had the lowest temperature drop. However, the fiberglass had the lowest temperature drop of all the commonly used and affordable types of insulation, and the Reflectex was the worst performing of the bunch. Based on the line graph, the vacuum panel was closest to the initial temperature line, and out of all the commonly used material, fiberglass maintained the highest temperature. The average temperature difference between inside and outside was 21.3 degrees Celsius, and the fiberglass had an average drop of only 12.35 degrees Celsius, which had the lowest temperature drop of the commonly used insulators. The box without insulation had the highest temperature drop of 19.25 degrees Celsius. From the most effective to least effective insulators was a vacuum panel, fiberglass, Reflectex, rigid foam, foam, and no insulation. So based on this, it can be safely concluded that based on most commonly used materials, fiberglass is a most effective insulator. However, the vacuum panel had a temperature drop of only half that of the fiberglass, though it is not commonly used and much more expensive than fiberglass. Obviously, the box with the most temperature drop was the one without any insulation. The hypothesis was accepted. This is because fiberglass is made out of tiny glass fibers that create several air pockets and eventually resist heat transfer between the two conducting surfaces on both sides. A benefit to society is that about 50% of energy money is spent is on heating and cool building bills. Heating on cooling bills. Adding effective insulation is a great way to save energy and reduce these bills. A thing that could have been done differently was to create 2 cardboard walls and place insulation between them to create a better simulation of a real wall. A possible error was that there could have still been leaks in the corner of the boxes, as all that was used was simple masking tape and not some advanced heavy-duty connection material. In the future, I can perform this experiment to see how much the temperature in each box rises. It will be interesting to see that most likely the most effective insulator in the winter would probably also be the most effective insulator in the summer because they work in the same way. Some other insulation material that was not tested includes a structural insulated panel, which is somewhat like a Lego block, and it replaces both the structural supports as well as the insulation in a thin and dense package. Sawdust can also be used, and it's inexpensive, but it requires frequent maintenance and is thus not commonly used. The vacuum panel was tested for future insulation because it is very good insulation, probably the best. It uses two walls with absolutely no matter in between them. Thank you for watching. Now basically this project got a first at regionals and a first at states. Everybody was shocked at this because it really didn't take that much work. That's the thing about PJAS. You need to be passionate and you need to follow the guidelines exactly. Insulation really took off as a category after my project. In fact, this year I believe 4 people in Springhouse are doing a project based on insulation. And if I know correctly, I was probably the first one, or at least the one that popularized the idea. Two of my younger friends did it, and it seems to be a very nice topic. It's a nice future minded topic and very relevant in today's society. Now, I'm surprised I did that well after 4 years after presenting. In a couple weeks, I will post my current PJAS project, and you could make the decision on how I improved over those 4 years. Thank you and goodbye.